So as we're looking at 1, 2, and 4 to start out with, and then we'll get to 3. 3 is a little bit different, but not much. The first thing, if we're adding and subtracting fractions, what do we need? A common denominator, correct? Now, y is the same thing as y over 1, right? So what would be my common denominator between 1 and y minus 5? Minus 5. So we need to have both of my denominators as y minus 5. The nice thing is the first one is already that way, so I'm going to leave the y on top. Now, the second one here, what did I multiply 1 by to get to y minus 5? Y minus 5, right? So I need to multiply the numerator by y minus 5. So if I'm taking 4y times y minus 5, what do I have to do with that? Multiply it to distribute, right? What's 4y times y? 4y squared. And what's 4y times a negative 5? Negative 20y. Okay. And now we have common denominators, so we can go ahead and add our numerators, right? So 4y squared, can I add it with anything? No, so we leave it as 4y squared. A negative 20y can be added with positive y. And what's negative 20y plus 1y? Negative 19y. And then our denominator stays the exact same. Then, before I check, what do I need to make sure I do with the numerator to see if I can simplify farther? Can I factor that numerator? Yeah, what can be factored out of 4y squared and 19y? Y. And what would I be left with? 4y minus 19 over y minus 5. And I'm always put that as parentheses. Is there anything I can simplify here? No. So I would either accept this answer or this one as well, because I couldn't simplify any farther. So both of those same. I just factor the numerator to see if I can simplify farther for you guys. Okay. All right. Any questions with that one? Okay. All right. Number 2. We have 3a over a plus 1 plus 2 times a minus 1 minus 1. And I'm going to go ahead and put that also over 1. Okay. What is my common denominator if I have a plus 1, a minus 1, and 1? A plus 1 and a minus 1. Why? Because we list everything in common, which there's nothing in common. And then we list everything individually, right? So I have to list the a plus 1. I have to list the a minus 1. Okay. All right. So now, if in that first fraction, I went from a plus 1 to a plus 1 and a minus 1. So what do I have to multiply the numerator by? A minus 1, right? Because that's what's different. So what is 3a times a? 3a squared. What's 3a times a negative 1? Negative 3a. And you can see, doesn't that have a GCF of 3a? So that is the same, right? What did I multiply a minus 1 to get to my denominator? A plus 1. So I need to multiply by a plus 1 here. So 2 times a is 2a, and 2 times 1 plus 2. If I factor out a 2, wouldn't that be back to my original? Yep. And then from 1 to get to a plus 1 times a minus 1, I have to multiply 1 by a plus 1 times a minus 1. What do you guys notice about a plus 1 and a minus 1? It's a difference of 2 squares. And so what's going to happen to the inside? It cancels out, right? So what's a times a? A squared. And what's 1 times negative 1? Negative 1. Okay. So now, do we have common denominators? Yes. And if we have common denominators, Liam, put your computer away, please, because I know you're playing again. Okay. We can go ahead and combine like terms, okay? 3a squared, can I combine with anything? A squared. And what are we doing with this a squared? We are subtracting. So what's 3a squared minus 1a squared? 2a squared. Good. Okay. Then we have a negative 3a. What else is negative 3a alike with? 2a. And what are we doing with that 2a? adding. So what's a negative 3a plus 2a? Negative a. Okay. And then we are adding a positive 2. So this is positive 2, and we're subtracting what? A negative 1. So what's a positive 2 minus a negative 1? And then our denominator stays as a plus 1 times a minus 1. Now, we need to check. Can we factor my numerator? Yes. Oh, that'd be positive 3. Yeah, thank you. Positive 3. Now, can we factor the numerator? Well, let's check. What's my a times c? 2 times 3 is 6. And we're adding to be what? Negative 1. What times what is a positive 6? A positive 1 and a positive 6. A 2 and a 3, or negative 1, negative 6, or negative 2 and negative 3. Does any of these add to be negative 1? No. So we can't factor the numerator. So this here is my positive answer, or my final answer, not positive answer, my final answer. Okay. Do number 4 next. We have y plus 3 plus 2y minus 1 over y minus 2. So y plus 3, isn't that over 1? Over 1? Okay. So what's my common denominator between 1, 1, and y minus 2? Y minus 2, right? The last one stays the same, which is nice, so I'm just going to leave it as 2y minus 1. What did I multiply 1 by to get to y minus 2? Y minus 2, right? So what's y times y? Y squared. And what's y times negative 2? What did I multiply 1 by? Y minus 2 again, right? So what's 3 times y? 3y. And what's 3 times negative 2? Now, do we have like terms? Yeah, let's go ahead and combine our like terms. Y squared. Is there anything alike with y squared? No, so I'm going to leave it as y squared. Okay. Then we have a negative 2y. What else? 3y and 2y. So we're taking negative 2y plus 3y, which is 1y. And what's 1y plus 2y? 3y. And then we have a positive negative 6. So we have a negative 6 plus a negative 1. And we get what? Over y minus 2. Can I factor my numerator? No, because what times what is negative 7? 1 and negative 7, or negative 1 and 7. Does it add to be 3? No. So guess what? This is your final answer. Okay. All right. Last few. And then our last one, number 3. Okay. We have y minus 2 over y plus 1 times 1 minus 1 over y plus 2. Now, last time we FOILed this, didn't we? Yeah, I'm going to show you another way today. Orders of operations say I do what first? The parentheses. So can I do my parentheses first? Yeah. What is my common denominator between 1 and y plus 1? Y plus 1. So the second one stays the same, right? So 2 over y plus 1. What did I multiply 1 by to get to y plus 1? Y plus 1. So what is y times y plus 1? Y squared plus y. Can we combine like terms? Yeah. Is there any like terms here? No. So we're going to end up with y squared plus y. And then what is it to 2? Minus 2 over y plus 1. Now let me ask you, can I factor my numerator? Yes. What does y squared plus y minus 2 factor to? What times what is negative 2 that adds to be 1? 2 and 1, which one's negative? The 1. Yeah. Is everyone okay with that? Because let me ask you, isn't 2 times negative 1 negative 2, and 2 plus negative 1, isn't that a 1? Yeah. So that's that fraction. Can I simplify anything here? No. So I'm going to leave it like that. Let's look at the second one. 1 is the same thing as 1 over 1. So what's my common denominator between 1 and y plus 2? Y plus 2. So what did I multiply 1 by? Y plus 2. So 1 times y plus 2 is? Which makes sense because is it y plus 2 divided by y plus 2, 1? Yeah. Okay. Now, y, I can't combine with anything, right? But what's 2 minus 1? 1 over y plus 2, right? So do you see how we have y plus 1 over y plus 2? Now, what are we doing here? We're multiplying, right? And if we're multiplying, can't we just cross simplify? Yeah. And what can I cross simplify? Y plus 2's, y plus 1's, and what am I left with? Y minus 1. That's it. And that is your final answer. Guess what? If you guys look at your notes from last class, this was the exact same one we did, I'm pretty sure. We foiled it though, right? Did we do this one? Yeah. But we foiled it. Did we get the same answer? Yes. Does it matter which method you use? No. Personally, I like using orders of operation, doing the parenthesis first, but I wanted to practice FOIL with you guys. Okay. All right. Any questions from that? Is there any questions? I can't answer questions on quizzes yet, but next week we can. Is there any questions on homework from 6.6? I mean, I did assign the odds so you guys can double check your work, okay? But is there any questions that you guys can think of for your homework? Or do we want to wait till at the end of the notes? Okay, all right. So we're going to do, here's what the plan is, okay? Just kind of a refresher before we actually get started in the last one. Today we're doing 6.7, okay? Your homework is page 276, 1 through 29 odd. Again, I assigned the odd so that you can check your work, okay? Monday next week, we're going to review, okay? I do have like the review that's out of the book, but I'm going to add in some more before I actually let you go, because on your test, it's cumulative, so there's other review things in there, okay? So you'll have a review out of the textbook, but you also will do a review kind of bell work situation, okay? Wednesday is just going to be quiz over 6.6 and 6.7. So what we did this week, okay? And then if you guys have questions on your review guide, anything for your test is going to be Thursday next week, chapter 6 test. Okay? So that takes you up there, and then we'll start chapter 7 from there. And I'm going to tell you guys, it starts to get a little bit easier after the chapter 6 test, okay? Which will help you guys out. All right, any questions on what's going on the next couple weeks? Well, I guess it's really next week. All right, 6.7. Okay, let's pull back some 4th grade stuff, 3rd grade stuff. Divide 943 by 23 without a calculator. Use long division for me. 949 divided by 23. Do not give me decimals, give me fractions as answers, okay? I don't think 23 goes into that evenly. So no decimals, only fraction answers. Isn't this whole chapter over fractions? Yeah, so we're going to leave it as fractions. Michael, you look like you're thinking hard. Okay, so we start out with, all right, does 23 go into 9? No. So then we take 2 digits. 23, it goes into 94, doesn't it? How many times? 4. And what do I do from there once I get how many times it goes in? Multiply. So what's 4 times 23? 92. And then what do I do with these numbers? Subtract. So what's 94 minus 92? 2. And then I bring down the 9. And then I ask myself, 23 goes into 29 how many times? Once. And what's 1 times 23? And then I subtract. So what's 29 minus 23? 6, right? What is 6 known as? A remainder, right? So what is my final answer? 41, whole number, right? My remainder goes in the numerator. And what is my denominator? 23, my divisor, what I divided by, right? So 949 divided by 23 is 41 and 6/23, right? All right, what about 2,354 divided by 15? Okay. As you guys are working, does anyone know the name of the 2,354? Yeah. Are we okay? Okay. Right. Okay. Do you guys know what 2,354 is known as? Yeah. The dividend, and the 15 is my divisor. Yep. 15 is my divisor. So whatever gets underneath the division symbol is your dividend. And then what you're dividing by is your divisor. You guys probably haven't done long division in a long time, huh? No. Guys at home okay? You guys still awake over there? Thank you, Amelia. I see your thumbs up. All right. Can 15 go into 2? No. But can 15 go into 23? Yes. How many times? 1. And what's 1 times 15? 15. So now I subtract, correct? What's 23 minus 15? 8. And then I'm just going to bring down the 5. Okay. 15 goes into 85 how many times? 5. And what's 5 times 15? 75, yeah? And then I subtract, right? So what's 85 minus 75? Isn't that 10? And then I'm going to bring down the last digit, which is 4. Now 15 goes into 104 how many times? 6. Because 7 would be what? 105, right? Okay. So what's 6 times 15? 90. And what's 104 minus 90? 14. Okay. And then from this, 14 is known as my remainder. So we know 2,354 divided by 15 is 156 and what? 14/15. Good. All right. Now, if we wanted to do decimal, well, how would I have done this as a decimal? I would have continued. I put a decimal point, right? What number do I put? 0, and I bring down the 0 and keep going, okay? But guess what? Because we're going to be dividing polynomials, we have to deal with fractions, okay? So that's the reason why, okay? So our division rule, as we noticed, a dividend divided by the divisor is equal to the quotient, which is that whole number, right? Plus the remainder over my divisor, right? We didn't show the plus sign here, but that's the same thing, isn't it? 156 plus 14/15. Isn't that 156 14/15? Yes, okay. To check, what we can do is we can take the quotient times my divisor and then add your remainder. Why does that work? Because can't I multiply and then turn that to an improper fraction? And if that improper fraction is the same thing as that, that's how we check it, okay? Does that make sense? Okay. So now, how do we do this with long division, all right? Or with polynomials is what I meant to say, polynomials. Let's look at, and I'm going to do the last one here, G first, okay? So we have x squared minus x minus 12 divided by x minus 4, okay? Same idea as we did before. What goes underneath my division symbol? X squared minus x minus 12. And we always go from, in standard form, x squared to x to our constant, okay? If we're missing something, like if you look at this in B here, do you see how it goes a cubed to a constant? We will put like 0x squared, 0x. We want to make sure we go in order, and there'll be a reason why. What's my divisor? X minus 4. Okay, and I always like to put that in parentheses. Okay. Now, as we looked before, we always start with this first term, x squared. Okay, and we would see how many times does that go into x squared? Now, this is a binomial, so it looks a little more confusing, right? A little more confusing. We always just look at that first term, okay, in that binomial as well. X goes into x squared how many times? Or think of it this way, x times what gets me to x squared? Just x, right? Because x times x is x squared. Now, as we did before, we're going to take this x and multiply it by my divisor. But if you notice, this is a binomial. So what do you think I have to do when I multiply this by a binomial? I want to take x times x minus 4. So I need to distribute, right? What's x times x? X squared. What's x times negative 4? Negative 4x. Okay. And then what do we do with these? We always subtract. What's x squared minus x squared? 0. This should always be 0. If it isn't, you did something wrong, right? Okay. What's a negative 1x minus a negative 4x? So think, a negative and a negative make a positive. So what's negative 1x plus 4x? 3x. And then we're going to bring down the minus 12. Okay. And then we're going to do the exact same thing that we just did. Okay, so we start with the 3x. X times what gets me to 3x? Or what's 3x divided by x? 3, right? Is that a positive or negative 3? Positive, so I'm going to put a plus sign here. Okay. So now I'm going to distribute the 3 through everything. What's 3x times x? 3x. And what's 3 times a negative 4? Negative 12. And then I subtract, right? What's 3x minus 3x? 0. What's a negative 12 minus 12? 2 negatives make a positive. So what's negative 12 plus 12? 0. So do we have a remainder here? Our remainder is 0. So guess what? X squared minus x minus 12 divided by x minus 4 is equal to x plus 3. How do we check this? Could I take x minus 4 and times it by x plus 3 and see if I get to my dividend? Yeah, if I FOIL that, is that what I get to? Yeah, So no, that's just the first one, right? Okay, so it could get a little confusing, that's all right. Let's look at another one. Okay, let's go back to A here. What is going underneath my dividend? What's my dividend? What's going underneath my division symbol? 8x squared plus 6x plus 3. And that is in standard form, so x squared, x, and a constant. And what am I divided by? 4x plus. So now we start with this 8x squared and 4x. 8x squared divided by 4x, or 4x times what gets me to 8x squared? 2x. Okay, and then I'm going to multiply 2x by 4x plus 1, right? So what's 2x times 4x? 8x squared. If it's not, you did something wrong, right? And then what's 2x times 1? 2x. Okay. And now what do I do with these? I subtract, right? What is 8x squared minus 8x squared? 0. What's a 6x minus 2x? 4x. Good. And then we bring down the plus 3, right? Okay. Now we do the same thing we did again. We start with the first term, 4x divided by 4x, or 4x times what is 4x? 1, a positive or negative 1? Positive 1. So we put a plus 1. And now we distribute the 1 to everything. What's 1 times 4x? 4x. Those should be the same. If not, you did something wrong. 1 times 1 is 1. And now we subtract, right? What is 4x minus 4x? 0. Good. What's 3 minus 1? 2. Now, can 4x or can 2 be divided by 4x? Or can 4x times something get to 2? No. So this here is known as my remainder. Okay. So now, this divided, we know it is 2x plus 1. But in this case, because these are polynomials, we have to add our remainder. What is my remainder? 2. And what is my denominator? What did I divide by? What's my divisor? 4x plus 1. And that would be my final answer. Okay. Right? So when we look up here, my division rule, it's my quotient, which is 2x plus 1. Sorry, you can't see that on my screen. 2x plus 1 plus my remainder, which is 2, divided by my divisor, which is 4x plus 1. Could I check this if I really wanted to? Could I find my common denominators and see if we end up with x squared plus 6x plus 3 over my common denominator? Yes. Okay. I'm not going to do that right now, though. All right. So what do you guys think of this so far? So? Yeah. All right. F. Now it's in fraction form, but what is my divisor here? It's my numerator, right? Now, we need to make sure we put that in standard form. What is my standard form? What would go first? 15x squared, then what? 34x positive, and then a minus 16. And then what am I dividing by? What's my divisor? 5x minus 2. Sorry, I don't know why. I didn't give myself enough room. Okay. All right. So let's start. Start with 15x squared. 15x squared divided by 5x, or 5x times what gets me to 15x squared? 3x. And then distribute, right? 3x times 5x is 15x squared. 3x times a negative 2 is negative 6x. And now we subtract, right? What's 15x squared minus 15x squared? 0. A negative and a negative make a positive. So what's 34x plus 6x? 40x, is that right? And then bring down the minus 16. Now, we're looking at 40x. 5x times what gets me to 40x? 8, positive or negative 8? Positive. And then we distribute. So positive 8 times 5x is 40x. A positive 8 times negative 2 is negative 16. And then what do? We subtract, right? What's 40x minus 40x? 0. A negative and a negative make a positive. So what's negative 16 plus 16? 0. So do we have a remainder here? No. So what is my dividend? 3x plus 8. What's my quotient? 3x plus 8. And there you go. And we can check by taking 3x plus 8 times 5x minus 2 to see if we get to that. So if we FOILed it, would it get back to that original dividend? Okay. All right. Let's look at B. What is my dividend? 2a to the third plus 5. Now, what did I say? We want to make sure my dividend always decreases in standard form, right? My exponents. So we have a 2a cubed. Do we have an a squared? No, so I'm going to put a 0a squared. Is that okay? Is that the same thing? Yeah. Do we have an a? A single a? No, so I'm going to have a 0a. And then do we have a constant? Yes, a plus 5. And I'll show you why we have to have those. And then what am I dividing by? A minus 3. Okay. All right, so let's start out. 2a cubed and a. So a times what gets me to 2a cubed? 2a squared, right? And now what do? We distribute, right? What's 2a squared times a? 2a cubed. And what's 2a squared times a negative 3? Negative 6a squared. Do you see why we have these a squareds here to kind of match up? Because we can't combine 5 and 6a squared. You will always have those exponents. So that's why I added them in there for you. Okay. And now we subtract. What's 2a cubed minus 2a cubed? 0, right? 0 minus a negative 6. So a negative and a negative make a positive. So what's 0 plus 6? 6a squared. Bring down the 0a. Okay. Is everyone okay with that so far? All right. 6a squared divided by a, or a times what is 6a squared? A times what is 6a squared? 6 and a. Is it positive or negative 6? Positive, so I put a plus sign. Okay. And now distribute. What's 6a times a? 6a squared, perfect. What is 6a times a negative 3? Negative 18a, right? All right, and then we're going to subtract, right? What is 6a squared minus 6a squared? 0. A negative and a negative make a positive. So what's 0a plus 18a? 18a. And then we have a, bring down the plus 5, right? So now 18a and a. So a times what gets me to 18a? 18. Positive or negative 18? Positive. Okay. So what's a positive 18 times a? Just positive 18a, right? And what's 18 times negative 3? Negative 54. Okay. And then we subtract, right? So what is 18a minus 18a, 0. A negative and a negative make a positive. And what's 5 plus 54? 59. Do we have to go any farther? No, because a times nothing gets me to 59, right? So 59 is known as my remainder. Okay, so now what is my answer? Okay, my answer is we have the 2a squared plus 6a plus 18. And then what do I have to do? I add my remainder over my divisor. And what is my divisor? A minus 3. And there you go. And if you really want to check that, could you find the common denominators and see if my numerator gets 2? This a cubed, 2a cubed plus 5? Yeah, okay. All right. So what are you guys thinking about this so far? Not too bad, not too. Okay. All right, let's go ahead and do, we won't do all of these. Let's do C. Yeah, go ahead and do C for me. Whoa. Sorry, guys. Go ahead and do C. I'm just going to write it. This one's going to be a little long, huh? Nice thing is this one had all the exponents, right? So did I have to put a 0x something in there? No. I actually think dividing polynomials are better than dividing numbers. There's not too much thought. You agree so far? Like I said, it's not as bad. The good thing is, guys, you will see this again in Algebra 2. All this chapter is a lot of Algebra 2 stuff for you guys. So you're ahead of the game when you get there. So when they start doing it, it's amazing. So what did you guys say for the first one? 2x times what gets me to 6x to the 4th? 3x cubed, right? Yep. If you notice so far, it's only going down by 1 every time, right? Okay. So what's 3x cubed times 2x? 6x to the 4th. And what's 3x cubed times a negative 1? Negative 3x cubed. Good. And now we're going to subtract. What's 6x to the 4th minus 6x to the 4th? 0. We need to change, right? So what's a negative 1 plus 3? 2x cubed. Perfect. Bring down the negative 11x squared. And if you notice, I'm only bringing down 2 at a time because we're dividing by a polynomial. Okay. So it doesn't get like super long. All right. 2x times what gets me to 2x cubed? X to the 2nd, right? Positive or negative? Positive. Yep. So I'm going to put a plus sign. What's x squared times 2x? 2x cubed. Yep. X squared times a negative 1? Negative x squared. And now we subtract. 2x cubed minus 2x cubed is 0, which is nice. We need to change, right? So it's a negative 11 plus 1. Negative 10x squared. Is everyone okay with that? Bring down the plus 9x. Okay. All right. Now, this was negative here. So 2x times what gets me to a negative 10x squared? Negative 5x. Perfect. So I'm going to put a minus 5x on the top. Perfect. Now I got to distribute a negative 5x. Negative 5x times 2x is negative 10x squared. Negative 5x and a negative 1 is a positive 5x. Is everyone okay with that? And now we subtract. For this bottom one, the first one now, a negative and a negative make a positive, right? So what is negative 10x plus 10x? 0, right? But now we still have to subtract the second one, right? So what's 9x minus a positive 5x? What's 9x minus 5x? 4x. Is everyone okay with that? Okay. And then we bring down the minus 2. All right. 2x times what is 4x? 2. Positive or negative 2? Positive, so I'm going to put a plus sign. Okay. 2 times 2x is 4x. And 2 times negative 1 is 2. Now, when I subtract this, what am I going to get? 0. So do we have a remainder here? No. So this up here is my final answer. All right. Any questions with that? Out of H, D, and I, which other one do you guys want to do? These bottom two, these are a little advanced on that. We might hit that on Monday, just kind of review. There's no assignments on these two, so you don't have to worry about those. Okay. So do we want to do D, H, or I? D. Okay. All right. So D, we have M over 8 over 5M over 8. That seems really confusing, right? What if I rewrite it like this? M over 8 divided by 5M over 8. Isn't it the same thing? Do you guys know how to do that one? Yeah, you do. So we're going to keep it, change it, flip it. So you guys actually picked the easiest one, didn't you? So M over 8 times 8 over 5M. Do the 8s cancel? Do the M's cancel? What's left on the numerator? 1. What's in my denominator? All right, I'll do one more. Do you want H or I? I. H, I. Does it matter? No. Actually, let's do, I gave you guys both. Let's do H. Why? Because if you look at the numerator, what are we missing? A Y. So what do we have to add in? A Y. But what else? A 0Y, right? All right. So let's look at underneath 9y squared. We need a y, so we're going to put a 0y plus 6. And then we have 3y minus 1. All right. 3y times what gets me to 9y squared? 3y. Yeah. What's 3y times 3y? 9y squared. And what's 3y times negative 1? 3y. Do you guys see why I added in that 0y? So we have like terms. Let's subtract. What's 9y squared minus 9y squared? 0. A negative and a negative make a positive. So what's 0 plus 3y? Bring down the plus 6. 3y times what gets me to 3y? 1, positive or negative? So I'll put a plus sign. And now we multiply. What's 1 times 3y minus 1? 3y minus 1. And then we subtract. Did you get it or no? All right, give me a second. I'll get it for you. What's 3y minus 3y? 0. And what's 6 minus a negative 1? 7. Yeah, because change, right? Can 3y go into 7? No. So this is that's my remainder. So what's my final answer? We have 3y plus 1 plus 7 over what? 3y minus 1. There you go. Perfect. All right. How do you guys feel with this? Not too bad, right? Not too bad. A lot of work, but not super difficult, I think. I think this is the best. I don't know. I like long division. Okay. All right. So as